speaker is Kent Gruber with Plotting Hackers, Visualizing Attack Patterns.
All right, this worked? Cool. All right. So yeah, Plotting Hackers, Visualizing Attack Patterns. Let's get into that. Hi, my name is Kent. I go by PyCat online a lot. I do security research and development, a little bit of art on the side too. I kind of like mend the two sometimes. We're going to kind of see that here, a little bit of visualization, a little bit looking at data and seeing where those kind of merge, right? I consider myself a polyglot, meaning I learn multiple programming languages and I know them instead of like Italian or French or whatever. These are the programming languages that I program in the most in my spare time. Python, Ruby, Go, Crystal, and Bash, whatever kind of piques my interest. A lot of object-oriented programming languages, but also functional. And I kind of like blending the two a lot. Anyway, I have a blog. You can kind of read blog posts on plotting hackers, visualizing attack patterns. I'll kind of get into a little bit, but I'm going to expand upon this. Yeah, I've done a whole bunch of other blog posts. I really like sharing the research that I do and like putting it out in writing so that people could look at it, critique it, and see if I'm doing stuff that it's good or not. And people seem to like it, which I'm kind of happy about right now. Though you can go look at it and see for yourself. You can find me on Twitter. I basically only perpetuate my research on Twitter. And I'm really humbled that my last talk, Converge, Violent Ruby, it was received like really well, and I got a bunch of response on Twitter, and I was just really humbled by this. And I'm like really happy that at least I was able to like get this kind of response, and people are like tweeting out about it. And I don't know, this kind of stuff like really like touches my heart because like it's a community kind of thing, and I really enjoyed like scrolling through this and seeing my friends and retweeting it, stuff like that. And it's on YouTube and had a bunch of views thus far, and I don't know, I really like it. So this is the kind of stuff that I like put on my Twitter, basically, stuff that I do. So like, this is a friendly interface to IP tables. It's a firewall, right? You probably use it, or if you haven't, it's interesting to check out. So this is a friendly interface to that for Ruby, and it has some like Easter eggs built in, so like a squid and a giant squid. That's the mascot for IP tables with a Z. Why not, right? You can find a lot of my research, all of my open source projects on GitHub, because I really like that, IP tables especially. And then I'm building stuff on top of that. So it's basically like a library, and then I'm building stuff on top of that. And you can too if you wanted to. But basically this is like an RSpec test suite that I'm building with IP tables in order to basically test firewall rules and see if they match a specific kind of like rule set that I want it to based on these RSpec tests that I write. Anyway, and then if it passed, green; if it failed, red. So you can kind of describe how you want your stuff to be and then verify that it actually is that way. So yeah, and then I'm making a guide for that on GitBook. It's really cool. I really like documentation. And GitBook's an interesting platform. It's not perfect, but it's definitely an interesting platform to check out. And so I'm like going through like installation processes and stuff like that, because I want people to use it. And so I want my stuff to be really friendly, really accessible. That's something that really like matters to me, because I want, if you guys wanted to like use it, like it should be pretty easy for you to pick it up and go use it, right? So guides, stuff to just like describe what this is kind of trying to solve essentially. So basic examples, all of that kind of stuff you can get started with, dropping stuff, and I spelled IP address wrong, but that's fine. It's open source, and you can change that. I don't care, right? So allow all typical HTTP traffic, just port 80 kind of stuff. And it's kind of a friendly interface, and you don't have to stack it like this, like these kinds of like protocol port states thing. I just kind of like doing that. You can do that in Ruby, so I like it. You can also, like, if you wanted to, you can like make that in like a config JSON and load that up, because it's just like a key value pairing sort of thing. You could do simple things like check if stuff is user-defined. This is like checking the default table. You could check like any other table in IP tables if there's a user-defined chain. Stuff like that. You can check packet count, stuff like that. Anything you could do in IP tables, I wanted this interface, so I could just do it in Ruby. Where is this? Though it's missing the world. That's fine. Anyway, so you could just basically, another application I wrote, you can just give it an IP address or a domain, and it'll use ipinfo.io, and you have like a couple of thousand free requests or whatever that you can use per day to like get the location of an IP address from the command line, and just do gem install where is this. So we're going to use it to look at some attackers because we have their IPs, right? BetterCap is a project that I contribute to, and I really like Evil Socket. Just want to give out a little love to him. And I've like put the missing rainbow option inside of BetterCap so that whenever you want to like do BetterCap, which is a man-in-the-middle framework, you can have a little rainbow option so you can have rainbow output in your terminal. Just fun stuff like that. It's kind of like charming. Like, for example, like EtterCap doesn't have that, but BetterCap does. Anyway. So plotting hackers, right? So that stuff and now this stuff. So like, what is that? Well, it's sort of like Kent did some stuff with graphs and learned some stuff, and so I want to share that with you, because like, sharing is caring, and I don't consider myself an expert by any means, but I figure if I want to like work towards that, I should like start like looking at that stuff, right? Like start playing around with it and like really like looking at my logs, collecting them, figuring out like what are the best methods to do that, because it's more than just like visualizing the logs, but like making sure you have the logs to do the visualizations. Like you don't just have like 30 days worth of logs, maybe that's not enough, or maybe you actually have enough logs, like maybe your application isn't logging enough to actually make any deterministic things to do anything interesting, right? Anyway, sharing is caring, so that's why I'm sharing. Don't worry about that guy. So visualization, it's incredibly helpful, but if you get it right, and it's actually pretty easy to mess up, I learned. So we're going to kind of get a little bit into that. And I'm okay with messing up. It's actually kind of one of my favorite things to do. Not that I say like messing up is the best thing to do, but I feel like if you're going to get it right, you should mess up a few times, right? Like that's the only thing I've ever done is mess up a bunch of times. And then I figure I kind of get it right, and then I probably didn't get it right. I have to go back and then realize I messed up still, and then get it right. Like it's a continuous iteration, iterative process, right? So let's just kind of look at some like meta things. And this data is a lie, but like let's look at the current slides that I've had. And I added slides after I made this graph, but whatever. So the data is a lie, but like what's kind of a problem you see with that? Like I don't even know what the numbers are, for example. I can kind of get like, oh, okay, like there's been less cats than the total amount of slides, maybe, but I don't even know what that data is really representing, right? So like those kind of visualizations, it has to like mean something. And so if we like look at the slides 30, cats 8, I'm doing a little bit of JavaScript. This is a responsive chart, so I can just like hover over it. I wrote a library called PyCharts in order to build up these charts with Ruby. And I'm going to show you how to use that. It's pretty simple. But like, let's kind of like think about that. I don't know if that's like even correct. If I wanted to build that chart, though, like this is like the actual like code that I used to build that chart. I just made a chart, a pie chart, and then I added some data, the slides. That's like the total amount, the amount that didn't have cats, and then the amount that did have cats. And then I added those data sets to that chart, and then I rendered off that HTML. And let's like sort of think about that. Was that the correct way to visualize that data, right? Was that the most effective way to do that? Was it even like the correct way that we were counting up? Because like in a pie chart, things should basically equal 100%, right? And if I had 30 total slides and I had 8 cats, am I supposed to like minus the amount of cats from the amount of slides, and those are normal slides, and then those are cat slides? You kind of have to figure out like what is the thing you're trying to represent? What is like the story you're trying to tell from your data, right? So if we were to like look at this, so 30 slides, 8 cats, put our thinking caps on, 30 plus 8, that's like 38. Did we have 38 total slides? I don't know, because I actually added more slides, right? But we can like put our thinking caps on again. What if we did like 30 minus 8 to get that whole like those are the normal amount of slides, and these are the amount of slides with cats in them, and then we have 22. So that kind of equals that 100% thing, right? Getting in that pie chart, like that's what pie charts are basically trying to represent, the 100% total of things, and what a like percentage of like a piece of that data is making up that chart, right? So we look at that. So we have 22 regular slides and 8 slides with cats in them. But is that saying we have the same amount of cats per slide? Are we having 1 cat per slide? Is it a cat slide? Is it the same as a normal slide? Or there's like 2 cats per slide? Are we counting that right? So you kind of have to like think about those things when you're visualizing them. And that like metadata means something. And obviously this is kind of a trivial example. We're talking about cats and slides. Like, what are you talking about, Kent? Stop it. But it's kind of interesting when you start like looking at like a base sort of thing when you want to figure out like, do I understand like what charts are representing? And I did not know that whole 100% thing with charts. I guess I didn't really pay attention to math enough. And by like actually like looking into it and like looking at like what I was doing wrong, I kind of got that a little bit more. So anyway, so like maybe like, and then if you actually like did that whole math thing, the actual like percentage of the cats is more. So what you're getting out of it, you can get 2 different representations out of basically the same amount of data. It just depends on like what you've correlated that to represent, if that makes sense. So anyway, if like that was the fix, that's the broken, is it even fixed? Is it broken? I don't know. But you kind of have to like pick that and see if like what is your correct situation, right? I would say maybe the fixed one is probably more fixed than broken, but again, it's that per cat slide thing. Weird thing to think about, right? Anyway, we can get rid of that. But if we wanted to like look at that a little bit more, right? The amount of slides, the amount of cats, like when I was doing visualizations and I'm like representing data, this was a terrible way to do that because we could basically like get rid of like redundancies, right? So slides 1 and then cat 0, 1. So I'm basically getting, is there a cat in there or is not a cat in there? So I get like rid of like the amount of slides because there's always a 1 in there. Get cats 0, 1, and then I have an index because it's an array. So I'll just have 1's first slide, was there a cat in there or not? Second slide, if there's a cat in there or not. Anyway, so you can kind of figure that out. But if you're doing this by hand, which I was doing, you may actually come across some weird problems with that. But anyway, so we're assuming we have the total amount of slides. We're going to create a line chart now, because we're going to kind of pick up a new kind of graph, because pie charts, we overdid them right now. So slides, 1 through 30, to an array, and then we're going to put that data in there, that 0, 1 kind of stuff. We're going to add some labels, which is the amount of slides, 0 to 1. Those are just the indexes, right? And then we're going to add that data for the label cats. And we can look at that, and then what do you see with the problem with that? Well, this like 30, it's missing. What did you do? Well, you didn't put in the correct amount of data in order to represent like the amount of labels that you wanted, so you didn't get the correct graph, because I was doing stuff by hand. And we're going to get into like why that's so not okay to do most of the time. But you can expect to mess up, especially when you're just like picking it up, like right? It's like, do this, and then realize like what the problem is. Like, have questions about it. I'm going to get into like, we should really have questions about your data, so you can get answers from it. Anyway, so stats by hand, that's really LOL to do. And if you wanted to like not just represent cats, but like let's say we had dogs and we had birds, something to like compare it to, that's when you start getting like a little bit more interesting stories from that data, correct? So something you can kind of get into where you're like, I want to compare something to a known other thing, so I can kind of figure out like what are the comparisons that I can make from that. So anyway, context. That's a really big key for visualization in your data, in your graphs. If you don't have proper context, like what are you really even like reading from the graph, right? Like it could just mean anything if it's just a line that goes up and down. You kind of see, oh, there's a pattern that can definitely lead to something, but like what is that representing? So visualizing data, what data, and how. Those are good questions, right? So, like what platform you're on, Windows logs can be a little bit different than like a Linux logs, right? You have BSD, you have applications that are going to have their own logs. You have like custom logs that people are just writing in their own programming languages or whatever. Stuff that's like more common for web servers and stuff. Whatever your SQL database, maybe that has some logs going on, your NoSQL database, or just like, again, those custom logs that you may have come across, and then maybe you want to get some stuff out of it, or just not, you don't have a easy parser you can go get off of GitHub for some applications, and I've ran into that a bunch of times, so I had to like create my own parser to be able to visualize what's going on in those logs, and it was a really great exercise too. So anyway, logs. Ooh, on fire. Anyway, formatting. It's really interesting, right? So yeah, you have logs, but not all the logs are going to be the same, right? You have logs that are going to have like date in a different way than another log, and maybe they're on different systems, and it can get really weird, and maybe the log doesn't even describe like what host it's coming from correctly, or like maybe they all have the same host name, and it gets really weird like how you're going to correlate that if like maybe they're all concatenated into one on accident or something crazy like that. Anyway, so parsing, it's getting a weird challenge. You might get into some weird stuff like regular expressions, figuring out how that works, like it's some finite state machine stuff in order to parse some text. And we're going to do a little overview of something that I've been sort of playing around with when I've been collecting my logs, because collecting that at scale, or more than just like rsyncing it somewhere on a cron job, just like playing around with like those ideas, how to effectively collect those logs and then do visualizations on them. So we got our computer, right? I like visuals, and this is a computer. And you got some logs on there. This is going to be a little broad term, because basically logs, what are they, right? If we're going to kind of quantify them, well, it's sort of just like recorded computer data, right? So you can generate your own logs. Like, for example, if you're on a Linux system, you have like the proc file system that has a bunch of ASCII text that you could basically log into a file, and then you could pipe that up somewhere, and then you can do metrics on that. Like, you don't have to rely specifically on the logs that are only available to you all the time if you have control over your host, right? So you may want to collect a lot more than what you may have simply available to you in the first place, if you have that option. And it's really nice to have. And so you might have these application sort of things that are going on, and they may have some logs. And just like interesting sys logs, like off log, right, syslog, whatever you got. And then sort of like playing around with like what is a log sort of thing. Like a packet capture is sort of like a log in a way, where you're sort of just collecting network traffic, and it's in the log form of just basically a PCAP, right? So yeah, so you have all these logs or whatever, and then you want to take that data and you want to put it somewhere, because that's a nice thing to do with the logs, right? So those are just strings in the files. That's a string maker, a computer. That's in transit, magic. We'll get into why that's not magic. And then we can kind of question, like, should we push or pull our logs? If we're trying to collect stuff, let's say real time, if we're waiting on a cron job to then give us data every night or every week or whatever, then that's not going to be real time. I wouldn't even say that's like near real time. So if you want to have like active information on your data, you have to actively collect it. And so if you were just having like some sort of collection thing, and let's say our database was saying like, here, go get my logs or whatever with an rsync thing or whatever, and then gets our data, Another scenario could be just like there's some sort of agent on the box, or it wants to then go talk to whatever offsite database or whatever, but maybe it's piping somewhere with like some sort of log stash thing or whatever. That's cool too. But like, let's say that goes down. Let's say your centralized logging thing goes down. Well, are you prepared for that? I wasn't prepared for that, but I learned to be prepared for that. Anyway, so the storage, it should be off-site, right? Because you don't want to have like the circular sort of visualization, right? Where you can see that it's never really going anywhere else. So if the host went down, you don't have anything, you don't have any logs in theory, right? So those should be separate hosts. Those should be separate entities at least. And so then you could have like multiple hosts talking to like one collection, or you could have multiple collections talking to multiple hosts. And they can come from like multiple different IPs depending on how you want to have that set up, right? It could have stuff come in from the cloud and stuff that's locally, depending on how you want to have that all set up. But those are all things that become sort of security concerns, especially on the technologies that you end up picking. And I'm going to sort of get into some of that. But anyway, so put in your data, but a little bit, wait, there's more, right? So there's like that little middleman of how we're getting that data into the collection, right? So, because, oh no, oh God. You guys are getting a really good sweet peek. All right, so anyway, so there's a box. This is supposed to be magic, right? Remember the transit is magic? So that's magic square, that's why it's a cube. That was the joke there. Anyway, so it's not really magic. It's usually some sort of like voodoo witchcraft agent that, like, maybe you're not like looking at like what Logstash is doing under the hood, so you're just like, it's nice, I can like do grok stuff and like put it somewhere, right? So anyway, so that's probably going to live on the host, and then that's going to pipe the data. And then we have some data, and maybe we're collecting a whole bunch of data. We don't just have like a couple days worth. Maybe you have like years worth of data that we're collecting now. Maybe I have some questions about it. I want to search on that data. Well, depends on what technology you're using. Are you going to be able to search that fast enough? Especially if you want to do that real-time stuff, right? We're collecting stuff real-time, and we want to have like real-time sort of, or neo-real-time kind of questions and answers on that data. Well then, let's answer some of those questions, and let's just put like a search thing in front of that, right? And we're going to be Elasticsearch. But anyway, so we have this DB, and it's the Elasticsearch, the search instance, right? We're going to be agnostic about it for right now. So this DB thing, we're actually going to get rid of it. So we have this database, and we have this search thing. I'm going to kind of like explain. They're not like that different. Basically, you could have multiple databases talking to one search instance. You could have multiple databases talking to multiple search instances that are clustered together. You can kind of pick whatever suits your need, depending on like what kind of querying you have. But we'll get into that a little bit more. But anyway, so like a database I would consider a little bit more like non-actionable because it's rather slower. Well, the search engine is supposed to be fast. Like that's what it sort of will, brand itself on. It's a search engine, it's supposed to be fast. It indexes stuff so you can ask stuff of it really fast and get those answers. So yeah, like basically one's searchable and one's not really that searchable, though you can search it. You can obviously do queries on a database. Like it's a very easy thing to do. So we have a database though. You can kind of pick like what database you want, right? MySQL or a NoSQL database. We can kind of not talk about like what is like NoSQL or whatever. But anyway, you can pick one of those or do whatever you want or not. We could just use a search engine, right? Or we could just like pretend we could just like Google everything on the internet and then have the Google be our search engine, but that could be a little silly. So we're going to use Elasticsearch. Elasticsearch is an interesting product, though security is something we're going to kind of get into because, yeah, it's really great. We can ask questions about our data. We have all this stuff we're piping into it. Are we doing that securely or not? And if you read their documentation, it gets kind of weird. But anyway, so this is our little like pipeline dream sort of thing. We kind of have to figure out the balance of like what works for your organization, what works for you. Like this was able to work for me pretty fun in like a lab sort of environment to like test stuff out and like play around with Elasticsearch and MongoDB and replicating stuff because that's just kind of interesting stuff to play with, especially you can then like watch that internet traffic and see what that looks like. But so you find your balance, and then because it may be a little bit more unique to you, you're gonna have to figure out the system that works for you. Like if you are okay with getting stuff in a cron job, or you do want to have that real-time kind of stuff. So like, what were we doing again? Like, yeah, we're like 130 slides in, and again, like, I added more slides, so, whew, jeez. So visualization, right? We could get like alerts from it, or we could just get like learning from it. Whatever you want from this, you should do visualizations atop your data, because it gives you better context. So like you have like all this stuff, and we're basically trying to get pretty lines that do pretty colors and show me trends so I can figure out like what's normal and what's not normal, figure out baselines and figure out what are averages, and then kind of figure out like what's going on in my system more than just like watching logs come down and like blankly staring at them. Because I've done that all the time too, and it's fun to do. I enjoy it, and I love putting colors on top of that and trying to like do fun stuff with that. But trends in figuring out like what's going on, again, near real time or even after the fact is incredibly useful for even just understanding a system. So you put the data there and then you get charts. So people use the elk stack quite a bit for this sort of thing. And it's a really powerful sort of like suite platform kind of thing. Elasticsearch, the company, puts it together, but you have your database in Elasticsearch, you have Logstash, which pipes stuff somewhere basically to Elasticsearch, and Kibana, which will visualize the stuff on top of Elasticsearch. And now it's become like a more of a full-fledged Java app where it does more things on top of that. In fact, like any of their security stuff that they sell is basically something you just throw on top of Kibana. So that's kind of interesting, but we're not going to use Kibana or Logstash. We're actually going to kind of re-implement Logstash, and then we're going to not really re-implement Kibana, but we're going to do visualizations without Kibana. Anyway, and then we're going to actually do it without Elasticsearch too, because we don't need to all the time. But anyway, so this is not an elk. It's actually a square. The emoji doesn't work right now, but that's fine. So custom stuff, right? Real gangsta hacka stuff. Eventful. Again, my emoji's gone. It was an owl. And it was awesome, trust me. Just like look at your emoji owl thing on your iPhone or whatever, go on Twitter, look for emoji owl. It was there. That's what that box should be. But that's fine. Log management and visualization, because I needed my platform, that whole like pipeline that I was building up. Well, I kind of wanted it to be like in code, and I called it Eventful because I like putting like projects that I do behind names. This one isn't really like open source since it was just sort of like something I'm kind of putting together for fun. There's no like real, you'll see what's going on here. Anyway, it's built in Ruby. And it's interesting, you have Sinatra for a lot of APIs that are going on here, because basically what we're going to do is we're going to build APIs to help manage our Elasticsearch thing and basically build a proxy to our Elasticsearch. Because usually what people do is you put up Elasticsearch, and then they're like, yeah, we don't have security by default. Like if you want to talk to Elasticsearch, the default way to do that is HTTP. If you're going to do any sort of stuff over HTTP that's unencrypted, that's bad to do. So by default, you're in a lot of problems. So what they basically ask you to do is go figure out security on your own or get our XPack thing, and then just put Nginx in front of it or whatever. And I decided to basically make my own proxy to kind of, I don't know, have fun stuff with Ruby, because I can do that. And so again, back to that research sort of thing. And then I'm going to use Chart.js to do some of that visualization, because I find that a really fun platform to work on. And it's better, I would say, than Google Charts, because I don't have to like have like internet connection, for example. I don't have to like trust Google. That's scary to me, I guess. I don't know. But anyway, so Chart.js, it's open source. It's really great. And I have PyCharts, which is a Ruby gem, in order to work with Chart.js. So really easy to work with. And then Elasticsearch, we're going to look at that. And so we're going to have that proxy, right? And then there was that owl emoji, and it was awesome. And why? Why owl emoji? So yeah, Elasticsearch can get a little scary sometimes if you start looking at documentation. It has no concept of a user. Essentially, anyone can send arbitrary requests to your cluster as a super user. Like, that's kind of interesting, right? And I'm just copy-pasting off of their website right now. And you can go look it up yourself and prove me wrong or whatever you want to do. Like, that's why I'm, open sourcing or like talking about this, right? But like this is a weird thing. And end users can provide scripts, have shell access to your host, okay. It has really shield, but then that got depreciated. And then getting started with security, they literally tell you to start doing curl over HTTP and then set up SSL. And I figured like that should have been the first step, right? Like I figured they're just getting a little bit of the steps a little bit wrong, I think. Though you can kind of argue maybe we're for on-local hosts, and then for sure like no one can sniff on our traffic, right? I don't know if they even say like spin this up in like an EC2, for example. I don't know. You get into like really weird instances where you're like, I'll ask companies, do you use Elasticsearch? And I'll ask, how do you secure it? And that can be an interesting question, because I don't know, not everyone's really thinking about like how my security like platform is going to be secure and not, because basically you're going to throw the logs into it and then maybe get alerts or whatever that case is. So you have to like look into your security platform, like, is that secure? Is that set up correctly? Because then you're just like logging all of your stuff over HTTP. I can sniff on that, right? Like, so interesting. So anyway, basic security measures in place. So they strongly recommend you set up SSL stuff. Though they don't really give you a way to do that unless you get their XPack stuff, or you're just going to buy their platform in the cloud or something like that. So again, I'm going to build my own sort of answer to that with Ruby and Sinatra, just doing my own self-signed SSL cert, because that's fun. Anyway, and so if like that sort of stuff is going on, that can only get bad one day. So fun. Logs, shall we? Yeah, metrics. Ooh. So like this is like a typical kind of like off log sort of thing. Ooh, possible break-in attempts. That's really fun. And that's an SSH. Those are SSH connections. People are trying to brute force this SSH box that had up. It was just a random VPS thing. If you spin up a VPS box that has SSH access, people are going to come attack it. And then that's interesting stuff that you can just collect. Now, you could just like set up fail to ban. It depends on what box you're running this on, right? But you can set up fail to ban and just like kick them off whenever they do enough connections. Or you can just like, accept their connections and then just like look at that data afterwards, right? So that's what we're doing here. If you wanted to, if you didn't want to just rely, again, on logs that are available to you kind of like by default, you could also use like any of the stuff in like the proc file system on Linux, for example, if you're on a Linux host. Because this is, again, like ASCII readable text that you can then just like parse out pretty easily. And for example, like this netstat stuff, if we're in procnet, and then we go to like procnet, and then we cat netstat, we can see this kind of like very unhuman readable kind of mumbo jumbo. But we can read a little bit like syn cookie sent, syn cookies received, blah, 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 and then it maps to another line underneath it. So anyway, you can then parse it out and then do whatever you want with that. But kind of first an overview of that eventful thing. Why not? So Proxy Web Gem auth, this got really crazy. I had a lot of fun with this though. Like I built a whole bunch of pieces of this, and then I ended up sort of ignoring them too, because then it got really complex. But I ended up sort of enjoying like building this kind of complex like system, and then like kind of like tearing pieces of it down, being like that was too much. But again, learning experiences. So again, I wrote this proxy, which is basically this little API that's going to talk to Elasticsearch instead of someone having to talk to it directly if I'm trying to collect stuff remotely. And then authorization mechanisms, because Elasticsearch doesn't have any concept of a user. I like having concept of users, especially if I'm going to have maybe multiple people in an organization have like loggers are collecting stuff, or I'm going to have like maybe just multiple instances on multiple boxes. They're going to all have their own authorization to talk to Elasticsearch, so that I can change one of them instead of they're all getting compromised. That kind of stuff, right? And then a web kind of interface would be really nice in order to visualize this stuff. You can kind of build this up as crazy as you want, or you can just do very simple Sinatra, like literally like 13 lines of code to get a chart. And then command line kind of interfaces are really awesome, and we're going to kind of get into that. An API, all that kind of stuff is just because curl is really fun. And then gem would be like the ideal way to do this, because it would be a really simple distribution for you just to do gem install eventful logger. It's not a real gem, so you can't do that, but you can steal that if you wanted to. And then, yeah, so what does like this authorization thing look like? Well, it's an authorization API. And then we can just like build that up with Sinatra, a little bit of secure random date time JSON, and you can kind of build this up as like secure as you need it, but if we're just kind of like building up a thing for fun, we can kind of play around with this, right? Like setting this unicorn custom value, which is going to be like this default user instead of root. Why not unicorn? I'm having fun. And then a custom header, love Ruby, why not? And then a token thing. And basically what we're doing here, this authentication, you see I'm doing like this Redis Lite and then equals like this little like brackets. Well, that's just a hash. So Redis is a key value storing database sort of thing. So I'm kind of like playing like this is Redis Lite. You just talk to it over HTTP, and then you can store values and you can talk to it over it. Anyway, so and then I'm going to configure it. I'm going to enable sessions just for fun, honestly, and then I'm going to use rack SSL. And I accidentally did underscore undercase in Vim. So you have to do uppercase for those, but I was late last night and I was copy pasting stuff into stuff, and then Vim, dang it, why? Anyway, and then self-run, I'm going to set the IP that I'm going to be listening on, so I'm going to 000, port that I'm going to listen on, and then the cert chain private key, those are just the SSL things I'm going to have to set up. And then I'm going to set a header just for fun, and then whenever they get like the default path to like this API, this web server thing, we're going to redirect them to the login thing, and then we're telling them it requires username and password. And then we can get log on. We can post to log on and log out. Log out requires a token. Log in, you get a token once you log in with your username and password. And then post tokens, that's how you get the tokens if you are a unicorn user, because that's fun. Now, that authentication bit, if you can authenticate, in this case, I'm literally just checking if you gave me a username and a password, though you can get as complex as you wanted this in here. Like, if you wanted to set up LDAP, it's like literally an extra 10 lines. I don't have that here because it was late last night. I was tired. But so then we can check if something's authenticated. These are little helpers that we're basically putting into our code, because this is what's going to basically build up this authorization API. So check if you're authenticated, if you have a session user, generate token, validate token, delete token, and then at the very last line, eventful API authentication run, and then we give it those SSL files, and then we're off and running. And then we can curl it if we wanted to. Notice how I'm doing that TAC-K thing, because I'm using a self-signed SSL cert for curl, and curl would yell at me otherwise. But I can then see, oh, look, I logged in with username dogs, password cats, because I can give it anything. And then it's stored for this username, token, that. So that's kind of fun. So then if I wanted to, you can just log in again, and we can get the same exact token, because that's basically initialized in my Redis Lite sort of database, right? So anyway, so that's my authentication, and then users log out, their token basically is deleted. So like these ephemeral kind of instances of users, just basically for fun. So all of these would basically talk to this authentication API in order to have centralized sort of users going on, or some manner of users going on for this Elasticsearch thing. So anyway, and then all that data basically talks to this API. Your agent talks to that API, and if it's talking HTTPS, it knows what you're doing, and then that's awesome. So you send that somewhere, your API auth, you get with your token, and that gives you a response, and then you can talk to your proxy, and then proxy Elasticsearch, and then you can have some questions or whatever, ask your question with your web app, with whatever visualizations you got going on. And your proxy is probably going to be talking to Elasticsearch too, or your web app's probably talking to Elasticsearch too. We're going to do that over our proxy, especially because we could have this up in a different host if we wanted to, so it could talk. So question. Anyway, so this module eventful Elasticsearch proxy thing that I was talking about too. This is all the code for the Elasticsearch proxy, and I'm not going to go too much into depth with it because I have limited time, right? But basically, the Elasticsearch proxy class, I do the exact same sort of things, though, with that other API, but instead, all I do is I have this post, get, and get search, and basically these are just three Elasticsearch sort of commands that I'm emulating. Sinatra is a really great platform because basically what you could do is you could just do a catch-all, for example. You could do get and then catch-all or post catch-all, which is basically like a /*. And then if you had a client, like for example, you had the Ruby Elasticsearch client or Python or whatever, and basically all it's doing is talking HTTP to whatever host you pointed at. So I could point it to my Sinatra host, which is what I did, and then I got to see like literally what request it was making, and then I could emulate the response, which was basically setting the Elasticsearch client, basically gem thing. So settings, clients, index, and then I give it the query in the Ruby syntax to do that Elasticsearch thing. But I could then fine-tune things here. I could log every request if I wanted to. I could do whatever I wanted. I get a lot of really cool granularity, I feel, here. So yeah. And this would be that search thing here. So it's pretty straightforward. I just stored this client object inside of the settings in Sinatra, and then I can then do the search method on top of that. And that's the body, which is basically I'm parsing the request body, and then I'm rescuing if there's some sort of failure just for giggles, because then they just won't get any results. And I'm only talking to this, again, in my own like sort of research thing. There should be a way better way to do this if you're doing this in production. And you can, but right now, one line. I like it. So yeah, proxy question, talk to Elasticsearch, get your answer web app, and then you can see it, and it's awesome. And you can then have more questions on top of that, right? Because once you get one like query out of that database or out of that whatever data that you have, it could just be one log file that you're doing like awk commands on, right? But you have questions on it, and then you can go back and get more answers on it. The reason you do Elasticsearch is you can get those answers very fast, and then real time, because it's basically near real time, because indexing stuff for you, so you're not having to like go through, iterate a bunch of things. It's kind of already done that to cache some stuff. So yeah, and then let's say we wanted to talk to Elasticsearch proxy that we just created. I know I won't have time to go through everything that I want to go through, so I'm creating an HTTP sort of client here. Those are really simple to set up, but basically I'm in this client class, and then I just basically point it to the URI of the Elasticsearch proxy that I'm going to talk to. And then what I'm doing here is actually really fun. So while line equals gets, so basically what I'm going to be able to do is I'm going to be able to pipe any sort of like tailing command into here, and then each line that it gets, it's going to then log with that client. So, and then it's, in this case, it would actually do the response code if I did a puts. That was after my debugging. You don't have to do that .code thing. That's fine. But if you did like puts and then that, it would do the response code, or if it was 200 for good, right? So I could do something like this. So on my box that I want to then talk to my Elasticsearch proxy, right? I could just do tail tacf my var log off log, right? And then in like basically real time, put in my Elasticsearch instance by doing Ruby log pipe client. That's where I just put all that client new stuff and that the while gets. So I'm piping it directly into Elasticsearch after it's talking to my proxy. And so I don't know, that was kind of like a little fun enlightenment, and I could just like start just like real time pushing stuff off. I don't know, I really like that. And then I'm going to show you some more stuff. So that eventful like log management visualization, we're going to kind of like tear it down. But like basically you could like go off and like build, and I was planning on really building off this whole like web app thing. But like you get into like obvious problems, and I definitely wasn't in my scope to like finish that before this talk. But like you can still do visualizations on top of your data anyway. You can kind of then build up really simple applications in Ruby though. So anyway, do whatever you want. And so let's look at this auth log, right? We're looking at some authorization logs. This is a really fun log to look at because it's going to be there for you by default, for example. If we look at this one that I pulled down off of this virtual private server that we were running for just for a while, I could do cat auth log and then word count tac l. one thing that I did here is I actually can put all of the auth logs, all of the compressed auth logs, all into one, and then I just put it into one giant auth log. And we'll get into why that can be bad and whatever. So cat auth log and then word count tac L. That's the amount of lines in there. So that's the amount of lines in this log. So we could do simple stuff, Unix stuff. So this is where I'm kind of tearing down that whole eventful thing. In not every case, you're going to need that kind of level of sophistication, especially if you're just sort of getting into this log management, log parsing, getting visualization data out of it. Because you can sort of get the bare bones of that stuff by basically just doing basic awk commands, those basic, very simple pipe stuff, command line. Because basically all you're doing is you're looking at fields of the data, and you're looking at where the relevant fields are. You can do regex, and you can basically fix up those fields. Basically, all the regex is doing field checks too. I think it's a good regular expression to add some of that in there. So anyway, in this case, this head n auth log and then tail n auth log. I'm basically just looking at what was beginning or the end. But if I'm looking at the very top, it's in April 30th, and then April 16th is at the bottom. So interesting. So maybe dates got a little mixed up here when I put them all into one log. So if I was going to start looking at that, for example, the first line of the auth log, if I'm using awk, basically I'm looking at fields. So basically it separates it by a space, and then it puts it into this array. And so this is the first line out of awk, and basically I can print the month very simply here, which is going to be April. I could then do the first and second to get the day, the month, and then the day. And now this won't work for every log, but for example, this auth log thing, it works every time for me. If you come across a situation it doesn't work, please tell me, that'd be interesting. Anyway, so cat auth log, and then I can do this awk print 1, 2 thing again. I'm going to use another thing, Unix stuff, unique. So I'm looking at that, April 30th, May, April. So those dates are definitely not in order. So maybe I kind of want that though, because I want to see stuff in order, especially if it's something like a timeline. I want to see that in series, because that's sort of indicative of a timeline, I think. So cat auth log, I'm going to do some more awk stuff, and let's do another pipe. This is when we'll realize stuff gets kind of hard, and you can get somewhere with this, but you're going to run into some scale issues right away, even with yourself. So anyways, this auth log stuff, awk print 1, 2, unique sort, okay. Didn't really sort it right. We can look at, April 10th, awesome, 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 and then April 9th at the bottom before the May 1st and 7th. Okay, well, let's try to fix that, right? So how about we sort by month, and with the sort command, you can do man sort, and it does sort by month. April 30th again, May 1st, May, okay, this did not do that right. Okay, all right, let's do sort n, let's do numeric, that's a fun one. Dang, same thing? Oh, yes, the default. Okay, we should read the man pages. All right, let's do sort nk, but we'll use k, which is basically going to specify a different field. So we're going to basically do it by the second field in this case. And then we're going to do the sort tac m by month again. So we get May, awesome, April 9th, and we get stuff. This is awesome. We're going somewhere with this, right? But, wait, months... April, May. Dang it! It's reverse order again. So if I was going to read this line by line, I would see literally months in reverse. Dang it! So let's just look at some Ruby. Because it does some fun stuff for us. So we're going to use pry. I talked about this in my previous talk, but it's basically this REPL sort of thing. It's a breakpoint debugger. It's a really great starting point for a Rubyist or anyone that's trying to get into programming languages. Use a REPL. Trust me, use a REPL, whatever programming language you're using. Try to find a REPL, even if it's C. Using a REPL in C is actually kind of interesting. Anyway, so log equal log read lines dot auth log, whatever, and we can then check the amount of lines in that log. And remember, if we did that word count tac L, this is sort of the same stuff we're emulating here. Though I would argue this is way readable, way more readable. So how about we want to do some JSON stuff, because I like putting stuff into Elasticsearch, and Elasticsearch JSON, just for example. So I'll require date. Now we're going to get some date magic inside of Ruby. Require set. So basically, I don't want to check unique stuff. I just know it's going to be a unique set of stuff. So a unique set of dates. I have this little method for time info for each line. And essentially, I'm going to parse each line with that, and then I'm going to store it into this date set, and I'm going to sort by the date. And then I'm going to put that as JSON. And if we run that, that's what we get. And that's the series of dates in order in a JSON format, which we can start using in other languages, or we can just parse into another thing, or you wouldn't have to put this into JSON if we didn't want to. I just did it for fun. So yeah, we could do some date count sorting. This is great. So basically now I have the date, the name of the date, and then I have the count along with it. So each day, how many events occurred on that day. So now let's put that into a pie chart, right? So we have that JSON that we just outputted with pie charts. It can manage this really simply. So JSON, we're going to JSON parts that get stuff, because what we're going to do is we're actually going to pipe that Ruby thing into this Ruby, basically web server sort of thing for fun. So you'll see what that looks like, and then it's going to render out this chart. So Ruby dates from log, so we get all the dates and includes the counts. And then we're going to do this Ruby day stats chart thing. And what do we get? Woo! Awesome! But that's not the greatest thing in the world. Like we still need to look through that and have some questions on that, right? Like that's just a lot for me. So how about we kind of break that down a little bit more, right? So we got some interesting stuff out of that, right? Like we got to see basically most amount of dates, least amount of dates sort of thing, right? Quickly in a visualization. How about we look at kind of days of the week sort of thing, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday kind of thing, right? That could be interesting. Like what happens on a Monday compared to happens on a Tuesday, right? We could do that, and then we get some day stats from logs, and so it happens on Sunday, Monday, Tuesday. I could then parse that out, look at the values. Cool. I can map that into the appropriate format for my pie charts thing, which is basically what chart.js wants me to have. So I do my Ruby day stats from log thing that I just did. That is outputted as JSON, and then it's piped directly into that day stats chart thing. Pretty sure it's the exact same charts Ruby code too. Anyway, we get this. Woo! So we didn't have to change up our API to do this whole chart thing. We just had to put our information in the correct format. And then we can see by days of the week, basically, where it's happening most. But this isn't perfect either, right? I'm kind of maybe just hating on pie charts a little bit here. What I would really like is having maybe a trend. That'd be really nice. So I can kind of see what's happening here. I thought it was really interesting. Friday dips off like crazy. I don't know, are people just lazy on Fridays? Are people off drinking or something like that? You can kind of again, ask questions about your data. And then maybe go spin up more boxes and see if that's the same thing on multiple boxes on maybe different sort of virtual private instances, or have different sort of honeypot stuff set up in order to attract different type of attackers. Again, you ask questions, you have hypotheses, and then you can then basically prove or disprove yourself based on the data available to you. So again, I like thinking caps. So if I want to do that pie charts line thing, that's that keys, and then I'm going to get an average. So I had that one line. I like having multiple lines. What we could do is we could have an average, which is basically finding the thing through the center, right? So I see that's the average, and I see it fluctuates. This isn't perfect, but this gives us kind of a way we can just start putting lines that maybe mean something, or maybe don't mean the correct thing in this context. But averages are really easy to put. So yeah, we can put our thinking caps on and see if that's even what we want to have there, right? We can get some time info out of that. So what we're going to do is we're going to parse each line again, and then we're just going to split by those fields. And then what we could do is we have it by hour now. And so we have each event, and then we can see what's happening by hour, and then we have the average going through there. And then you can, again, have more questions. Maybe you want to go by hour. Maybe you want to start looking just on hour on a Monday, because that was for all days. Now, just on a Monday. How about on a Wednesday? That was the most events. So we can see it happened mostly at 1 o'clock for whatever reason. And then we can see every day, and we can compare each day, and then we can compare what's going on there. And if we wanted to, we could, with my pie charts thing, with Charts.js actually, you can just click one of them, and you can kind of then start basically figuring out comparing just a few of them instead of having just one big one, because that Wednesday one kind of not obscures the rest of them, but you obviously, that's the big one, definitely. How about let's look at these. Do we see any similarities or any correlations here that are kind of interesting? If we wanted to look at it by minute, right? So once we have this Ruby date, time, magic stuff, it's really easy to just do is it a Sunday question mark? Give me the minute, give me the hour, and I could just go through all 24 hours and plot something like this very easily. And then kind of getting back to that awk stuff, right? Because I like Ruby, I like using that, but I still like using awk. I still like parsing through my data to kind of ask questions about it in the beginning, if I have that available to me. So cat auth-log, I'm going to grep for invalid user, and then I'm going to do some awk magic again in order to get just the user out of that. And then I'm going to do some sort. I'm going to do unique counting, and I'm going to do some sort so I can get by the correct amount of uniqueness or whatever. And then I'm just going to look at the first few of them. And I can see 1 through 37, which is a fun number to find in numbers, especially when you're looking at hacker data, right? And especially for admin. Anyway, you can kind of look at the users that they are using the most, and maybe you don't want to set them. I don't know. So yeah, so let's look at the IPs, right? So we have just those fields. And again, like this maps even to like the Elasticsearch thing or the MongoDB thing or the MySQL thing. It's basically you put stuff inside of fields and you parse those fields and then you basically correlate them together and then you get cool looking graphs or whatever you want. Right? So let's look at the IPs and let's look at just the top few of them. We get something kind of interesting, I thought. 78 for the same like top 5 IPs, like that's the same for the admin user, just for example. I thought that was rather interesting. So I had a question about that. Let's investigate that. I'm going to cat auth-log grep for that IP, and then I'm going to work tac L, so how many events happen inside of that auth-log, right? It contains all of the logs for, or at least a couple days worth of the logs. So I can see that 1,056 for each of them. I think I missed doing one of them, but I think it was late. I was tired. Don't worry. So, so cat auth-log, and then I'm going to grep for the invalid user, and then I'm going to basically check, do they have the same kind of users that they're using? And it's like literally the exact same. So I can kind of have a question about this. Are they the same? Are they using the same sort of brute force techniques? Am I worried about that? Should I be worried about that? Should I collect that? Should I start basically figuring out that's a behavior that this kind of attacker is using? Or like, could I go look basically online for what word list they're using? Just sort of interesting stuff like that, because I have questions about the data, and then you can again answer it. So yeah, if we want to just like look at the dates, so what happened on the IP, like what are the dates that it actually attacked me on or whatever, right? So April 20th, April 16th, April 18th. So they all happen on separate days only, but they all happen in the same amount. So let's say we wanted to look at the IP address. So we have a question about this IP address. They had some behavior. We're kind of getting some interesting counter correlations between them. Let's just look at what other correlations we can get, right? So that where is this thing that I mentioned before? How about we where is this those IPs and kind of see where their host names are, where they're located, stuff like that. Oh, and if you look at the very bottom one, China backbone, whoop, whoop, CNC group. All right, so cat auth-log. We can check the beginning. And then we could check the end. Basically, we're getting the times out of this. So when did it start? And when did it end? Basically, when did it begin? When did it end? And hopefully, it's in correct order. Your logs, they're in the correct order. So maybe you should verify that first. But whatever. So we got this going on here. And then we can check the other one. All right. So it didn't happen at the exact same time or anything. But are they in the exact same in time frame? I don't know how to read 24-hour clock or whatever. So let's use some Ruby in a minute. So we have a whole bunch of them, and then I'm going to do some pry, and I'm basically going to parse that time thing. Basically, I just copy-pasted it. I could have done a whole bunch of other ways to do that. But basically, now I'm going to do is I'm going to have the first and the last, and then I can do a difference on them. And then if I wanted it by minute, I could do it by divided by 60. Basically, you get your math. You figure out like whatever the math you're trying to represent here. And so I wanted to basically like know how long the attack average was. So that was 43. This was 50. All right, so we can kind of get an idea of what's going on here. So basically what we're trying to basically analyze is those patterns. And your patterns may be different than my patterns. And if we have the same patterns, it'd be interesting if we could share those patterns and basically get like behavior analytics, right? Like figure out those behaviors, because you can do interesting correlations with that. Like pinning data on top of other data is a really interesting practice. And I didn't have a lot of time to get into that. Like I had like hundreds of slides. I love slides. Anyway, so you can go read more about this kind of stuff. I figured I'd get really short on time. So plotting hackers, visualizing attack patterns. And basically, you go through this, and I have an example fake log for you. So if you don't have something to like collect your own auth log, for example, this is just like a sample application log, custom application log that's modeled after real logs that I had. So there we go, some dates that are going on with it, and then you can build charts with it. And I show you using other JavaScript charting libraries. It's still Ruby, ChartKick, and then it's actually there's ones in JavaScript, and then there's in Python, so you can use ChartKick and a whole bunch of programming languages. And then it does some stuff for you, like gives you percentages. You can check whatever. And then basically you still have to parse stuff in the correct format. Like that's a huge thing. Like you have data, is it correctly parsed in the way that's my visualization platform needs? Well, if you're just using like elk, logstash, that kind of stuff, it kind of all ties in together, so you don't have to really worry about that all the time. Or do you? So when you don't want to use Kibana anymore, or you don't want to get tied down to that maybe. Anyway, so you can generate all sorts of weird things. Get attack timelines, have search address on top of that. Sinatra is a great platform, and then build interactivity to those charts, right? So you have interactive responsive charts that you can look at on your phone or whatever, and then you maybe want to search the IP address to basically narrow down like what are those patterns, right? So collect your logs, because if you're not collecting them, they're ephemeral. Like they will go away, especially like by default on a lot of distributions, like because otherwise like they're going to be there forever. Like, that'd be a little silly, right? So collect them, analyze them, and then question them, right? So if you're just collecting them, then it's kind of almost irrelevant for then when you maybe do have questions, like you won't know what are the norms in your data until you need to. Well, I want to just like know the norms of my data because that's the normal thing that I do. So find answers once you have those questions, and then obviously question those answers when you find the answers, right? Because that could be wrong, right? Like, especially if you're doing it by hand, you're doing it yourself, and you don't have anyone else to like kind of like question, am I doing this right? Or maybe you're scared you don't know math, whatever the case is, right? And then automate with the need. Ooh, all right. So it should be one word, right? But whatever. So automate the stuff that you're doing by hand because it'll save you all your carpal tunnel problems, and that's the end.